Hello friends, in this video we will discuss about how to use and apply kinematic equations. Please make sure you watch Kinematics Part 1 to Part 7, then go ahead with Part 8. We use kinematic equations for objects moving at constant acceleration and in a straight line. So, to use kinematic equation, first we have to choose axis. If object is moving in a horizontal direction like this way or moving to left or right, then we choose a x-axis. And if object is moving in a vertical motion or moving upward or downward, then we choose a y-axis. For example, a ball is thrown up or thrown downward. In both cases, we will choose a y-axis. Next, we have to choose the direction. Direction of object's motion is considered as the positive direction. For example, this car is moving to the right direction. Then, in this case, right direction is the positive direction and left is the negative direction. But if this car were moving to the left direction, then left direction would be considered as positive direction and right direction would be the negative direction. Same way, this ball is thrown up, so upward is the positive direction and down is the negative direction. But if this ball were thrown downward, then down would be positive direction and up would be the negative direction. So here are all the kinematic equations. First equation is V equals V naught plus A times t. V here is the final velocity or velocity at time t. V naught is the velocity at time 0 seconds, or it is also called as starting velocity or the initial velocity. A is the acceleration of the object and t is the time taken. Second equation is delta x equals V naught t plus half at square. Delta x is the displacement of the object here. It is also written as xf minus xi. X stands for position and xf stands for final position. Xi stands for initial position. Suppose this car starts at the position of 0, then xi would be 0 and it displaces 10 meters, then xf would be 10 meter here. The final position would be 10 meter and displacement would be the distance between initial position and the final position. So car displaces from xi to xf. So v naught would be the initial velocity of the car and v would be the final velocity of the car after the time t. Third equation is v square equals v naught square plus twice a times delta x. V is the final velocity, v naught initial velocity, a is the acceleration and delta x is the displacement. I have added two additional equations here. These two equations are derived from these three basic equations. These equations are used to find displacement delta x. This equation is specially for average velocity and this equation is same as the second kinematic equation. But here we use initial velocity. In the last equation we use the final velocity. This is the difference. Here are the steps to solve a problem using kinematic equations. Let's take an example for horizontal motion. Ellen is jogging with a velocity of 6 meter per second when she accelerates at 2 meter per second square for 5 seconds. How fast is Ellen running now? So step 1, write all the givens and to find. Let me tell you one thing. You can figure out givens by looking at their units. Like here unit is meter per second and here unit is meter per second square. Meter per second is the unit of velocity. So this must be velocity. Here it is written that it is velocity, but sometimes it's quite confusing in the problem. So in that case you need to look at the units. So 6 meter per second is the initial velocity of Ellen. So it's v naught. 2 meter per second square is the acceleration because meter per second square is the unit of acceleration and 5 seconds is the time. How fast means we have to find the velocity of Ellen. So we have to find v or final velocity of Ellen after time 5 seconds. So V naught equals 6 meter per second, A equals 2 meter per second square, T equals 5 second, and we have to find the final velocity V. So step 2, find a suitable kinematic equation. Now you have to look at all the kinematic equation and see which one involves all these 4 variables like V naught, A, T and V. So we have to find V, so we will look the equation which has V like this one and this one, these two. You can see this equation has delta x, so we cannot use this equation because displacement is not given. So we will use this one because we have to find V, and V naught, A and T, they all are given. So we are going to use this equation. Step 3, plug in values and solve for the answer. 2 times 5, this will give us 6 plus 10 equals 16 meter per second. So ln is running with 16 meter per second after 5 seconds. So it's the answer here. Let's take an example for deceleration. So a car driving on a straight track decelerates at a rate of 4 meter per second square. Meter per second square means it's a acceleration. For 8 seconds, it's time. Initial velocity of the car is 25 meter per second, so it's V naught. We have to find the displacement, that means delta x. You can list all the givens. Keep in mind, we need at least 3 givens to solve a kinematic equation. Here we have 3 givens, so now we will choose a suitable kinematic equation. So let's choose an equation. We have to find the delta x. So either we can use this equation or this one or this one. We have V naught, A and T. So V naught, we have T, we have A and T. So we are going to use this equation. Equation is delta x equals V naught T plus half AT square. Step 3, plug in all the values. A equals 4. Keep in mind it's a deceleration. So A equals minus 4 here. Car is moving in this direction. Car's velocity is positive, and deceleration means acceleration is in the opposite direction of the car's movement. It would be a negative acceleration. So here A equals to minus 4, 200 minus 128, 72 meters. So 72 meter is the displacement of the car. Let's take an example for vertical motion. Here a ball is dropped off a cliff. Suppose this is a ball and it is dropped from a cliff like this. So down is the positive direction, and here givens are 22 seconds. So this is the time. It takes 22 seconds to hit the ground, and it asks for how high is the cliff. When an object is dropped off, that means it has given no velocity. So its initial velocity would be 0. This is the first given. Second given is our time 22 seconds. In the vertical motion, when something is dropped off or falling freely, in this case there would be the gravitational acceleration g, that is also called as gravity, and its value is 9.8 meter per second square. So here acceleration would be gravity, which is 9.8 meter per second square. Here we will put positive value of acceleration because gravity acts downward and down is the positive direction here. So A would be the positive 9.8 meter per second square. Now we have 3 givens, so we can solve a kinematic equation here. Let's check for a suitable kinematic equation. So we have to find the height of the cliff. Height means this length, and this is also the displacement of the ball. So actually we have to find delta x. So we have the given V naught, T and A. So we are going to use this equation. Equation is delta x equals V naught T plus half AT square. Now plug in all the values. V naught equals 0. If we multiply any term to 0, that results in 0. So the whole term would be 0 here. A equals 9.8 and T equals 22. We got 2371.6 meters. It's height of the cliff. Here is the question of the day. Solve it to see if you get the right answer. Answer is given below in the description box. Don't forget to subscribe, share and likes for daily updates. Thank you.